Hi everyone. In today's lesson we're going to talk about expanding logs. Before we can begin, let's recall the following information. The first thing is that log of x is the same thing as saying log base 10 of x. Remember, if no base is written, it's always base 10. Log base e of x is the same thing as saying ln of x. So log with base e is always used as ln. And if you're taking the square root of something, it really means you're raising it to the 1/2 power. Cube root of something, raising it to the 1/3 power, and fourth root of something, raising it to the 1/4 power. So let's look at these log properties here. We have a product, a quotient, and a power. We call this rule right here the product rule because we have log base b of ac, meaning a times c, ln of ac, a times c. We call this rule here the quotient rule because we're taking a and dividing it by c. And we call this the power rule because we're taking some number and raising it to another power, a to the c power. So let's talk about what the expanded log forms look like. So if I have log base b of ac, if I want to expand it, I'm going to say it's the same thing as saying log base b of a plus log base b of c. Same thing goes if I'm given ln. There's no base for ln, it's just ln. So ln of ac would just be ln of a plus ln of c. So if you have a product in condensed log form, when you expand it, you add the terms. Notice how in an expanded log form there's 2 logs, and in condensed log form there's 1. Okay, let's talk about the quotient rule. So if I have log base b of a divided by c, in expanded form we're just going to subtract. So this would be log base b of a minus log base b of c. Same thing for ln with no base, so ln of a minus ln of c. Okay, the last rule is called the power rule. Now this one's a little bit funny. When I take log base b of ac and I want to expand it, basically what you have to do is take this power, and this is my hint, drop it like it's hot. So we've got a c times log base b of a. Same thing for ln. You have the power, you drop it in front, c times ln of a. Okay, I want to make one observation. When I have a product or a quotient rule, and I want to expand them, I get 2 different logs at the end when I'm expanding them. But if I have a condensed log form of this power rule, I'm dropping the power down, but I only still have 1 log. So when you have a power, you're not making it 2, but for the other 2, you will. Okay, let's try a few examples. So example number 1 says log base b of cd. Well, c and d are connected by multiplication, so I would go to the product rule, and I'd realize that I'd have to add. So this would be log base b of c plus log base b of d. And that is the expanded log form, and that's all you need to do. Okay, example number 2. I've got log base 5 of c over d. Now, c over d is a quotient, so we're going to subtract. So this would be log base 5 of c minus log base 5 of d. Okay, example number 4. Log base 7 of d to the 4th. So this is our power rule. All I want to do is circle the power and drop it like it's hot. So 4 times log base 7 of d. Notice again that there's only 1 log in this expanded form. Okay, let's look at example number 4. Example number 4 has got 2 things going on. We've got ln of a squared c. That really means a squared times c. So I'm multiplying. So you should be first thinking, well, since I'm multiplying those 2 things, I need an addition. So ln of a squared plus ln of c. Now, some of you may be saying, well, look, in here, this is a power. I've got a squared. So I actually have a power rule for the a, and just the c stays alone. So I've got a product rule here and then a power rule here. So this is like a 2-step problem. Now I got to take the power, drop it in front, drop it like it's hot. So 2 ln a plus ln c would be my final answer. Okay, let's look at example 5. So example 5 just says log square root of b. Well, I don't like the square root of b. I'd rather you write it as b to the 1/2. So I'm just going to change the problem to say log of b to the 1/2. Now what kind of rule is this? Is this a product, a quotient, or a power? Well, it looks like a power. It's something to something power. So you want to take the power, drop it like it's hot. So 1/2 log of b. Final answer. Okay, example number 6, I've got two parts. I've got a division, but then I also have a power up here. So really, this is the same thing as saying ln of a to the 1/2 over b. So I'm going to divide. So first I want to do a subtraction problem. So I've got ln of a to the 1/2 minus ln of b. We're taking these two things and dividing, so I need to subtract. And then I said, okay, I've got a power, drop it like it's hot, 1/2 ln of a minus ln of b. This would be your final answer, just as this one up here was your final answer. Now some of you are saying, well, I already see that and I can go straight to the answer. Do you need this step in between? The answer is no. As long as you get it right, we don't care if you have this step. Okay, let's try some examples on the next page. Okay, why don't you try example number 7 and example number 9 by yourselves? And then hit resume when you're done. No cheating. Okay, these should be your answers. Okay, so for the first problem, what I did was I first recognized that it was a division. So I said log base z of x to the 1/2, same thing as the square root, minus log base z of y. That took care of the division. Then I saw that this x had a power, so I brought down the 1/2. Everything else stayed. Okay, in example number 9, I noticed that I had a multiplication problem because I have a times the square root of b. I rewrote the square root of b as b to the 1/2. So I'm multiplying a and b to the 1/2. So I know that if I have a product rule, I'm going to expand it using addition. So I say ln of a plus ln of b to the 1/2. That takes care of the multiplication. But now I got to take care of this power. So b is being raised to the 1/2 power, and I got to drop that in front. And I've got ln of a plus 1/2 ln of b. Okay, let's look at example number 8. I'm taking the square root of this whole entire thing here, x over y. So we can write that as x over y to the 1/2 power. And we really know that that really means I can distribute the power into the top and into the bottom. So that's x to the 1/2 over y to the 1/2. So now I can use my division rules. I have a quotient, so I'm going to subtract. So this should be ln x to the 1/2 minus ln y to the 1/2. And I also have two powers in here. I've got the 1/2 and the 1/2. I can drop them both down in front. So I've got 1/2 ln of x minus 1/2 ln of y. Okay, now in example number 10, I've got a squared b to the 3rd power. My suggestion would be to distribute the 3 in. So then this would be a to the 6th, b to the 3rd. And now I do the problem just like I would before. So I have a product of a to the 6th and b to the 3rd. So let's expand that using addition. So log base 5 of a to the 6th plus log base 5 of b to the 3rd. And now we're going to drop down both of our powers. We got a 6 and we got a 3. So my final answer will be 6 log base 5 of a plus 3 log base 5 of b. Okay, look these 10 examples over. Star any that were difficult for you and make sure you come in with questions tomorrow. All right, the last thing I wanted to talk about were some important facts about logs and ln's, and then we're done. So the first fact is over here, log base b of b equals 1, log base b of 1 equals 0, ln of 1 equals 0, and ln of e equals 1. I can prove them for you using the loop-de-loop. So this really says b to the 1st power equals b. So b to the 1st equals b. That's a true statement. I could put any b, any base I want. So log base 5 of 5. Does that equal 1? Well, yeah, let's check it out. 5 to the 1st equals 5. Works for me. So any number I put in here or here has to be the same, and it always equals 1. Okay, the second example. Log base b of 1 equals 0. So let's see. Log base b of 1 equals 0. Loop-de-loop. We get b to the 0 equals 1. So anything to the 0 power equals 1. We could pick any base we want. Pick 7. Log base 7 of 1. Does that still equal 0? Well, let's see. 7 to the 0 power. Does that equal 1? Yes. Okay. ln of 1 equaling 0. Well, ln is the same thing as saying log base e. So log base e of 1, does that equal 0? Well, e to the 0 power definitely equals 1. E to the 0 equals 1. Anything to the 0 power equals 1, so that's good. And the last one is ln of e equals 1. Well, that's the same thing as saying log base e of e equals 1. And that kind of goes back up to this one. Log base b of any b must equal 1. Perfect. Okay, so let's do some examples that require us to use these rules. Why don't you take a minute, see if you can expand these 4 problems. Just expand them. Don't even bother about this. Just expand. And then hit resume when you're done. No cheating. Okay, these should be your answers. Okay, take a minute, copy down these 4 correct expansions. If you didn't understand how we expanded them, make sure you circle it and ask us in class tomorrow. But now I'm going to do the extension to simplifying them more using these rules. Okay, so log of 10. Well, we know that if there's no base written, then it's got to be 10. So log base 10 of 10, isn't that this? Log base 10 of 10, that's 1. So this simplifies to 1 plus log x. Final answer. Okay, let's look at example number 12. So ln of 4 minus 2 ln e. Well, ln e we have here, ln of e is equal to 1. So this is really 2 times 1, which is 2. So the final answer, I'm going to write on top here, ln of 4 minus 2. ln of 4 is a number. You can't just make this expression ln of 2. These two things are attached. So if it helps, write it like this. Okay, number 13. Log base 4 of 4 is just like log base 10 of 10, which always simplifies to 1. So this part is 1. Multiplying that by 2 plus log of x. Final answer, 2 plus log x. Okay, the last example, number 14, I see ln of e. ln of e equals 1, so minus 4 times 1. This is where I got ln of e from. And I also have ln of 1. ln of 1 is 0. So 0 minus 4, final answer, negative 4. Okay, I know this was a lot to take in. Please circle the questions you had difficulty with and don't feel shy to ask us in class. All right, have a good night.